Today we will discuss another technique of the indefinite integration, that is the integration of the rational functions by partial fractions. Very important technique of the integration. In indefinite integration there are three techniques. One is method of substitution, another is method of bypass, and another important technique is integration of rational functions by partial fractions. First, we have to look at which one is a rational function. A function of the form px by qx. If the function of the form px by qx is called a rational function, where px and q of x are polynomials. Then the function is called rational function. A function of the form px by qx is called a rational function, where px and qx are polynomials. They may be same degree or may be different degree. For example, suppose the function of the form 5x plus 4x plus 5 by s square plus x minus 2. This is a rational function, and here px is 4x plus 5 and q of x is s square plus x minus 2. Our aim is how we integrate this type of function by using the method partial fraction. First, we have to look at whether the rational function is proper or improper. Whether it is proper or improper. Proper or improper. If the degree of px is less than degree of qx, then it is called a proper rational function. Here it is px is of degree 1, it is a linear polynomial, but the denominator is a quadratic. So it is a proper rational functions. It is proper rational functions because the degree of px is less than degree of qx. That is a proper rational functions. When we apply the method partial fraction, first we have to look at whether the rational function is proper or improper. If it is improper, then we have to convert to the proper fractions, proper rational functions. Now this example is a proper rational function because the degree of px is less than degree of qx. Here px is a linear polynomial, means the degree of px is 1, but the denominator is a polynomial of degree 2. So the degree of the polynomial in the denominator is more than the polynomial in the numerator. So it is a proper rational functions. If the function is of the form x cube plus 1 by x cube plus 1 by x square plus x plus 2, this is a improper rational function. This is a improper rational function because here the polynomial in the numerator is a cubic polynomial and the polynomial in the denominator is a quadratic polynomial. So it is a improper. Then we have to convert to the proper rational function. Then we apply the method. So first, our aim to convert the rational function to the proper rational function. Proper rational function means the polynomial in the numerator, degree of the polynomial in the numerator must be less than the degree of the polynomial in the denominator. Then we apply the method for partial fractions. For example, Suppose the rational function is of the form 4x plus 5 by s square minus 5x plus 6. The polynomial in the numerator is degree 1 and the polynomial in the denominator is degree 2. So it is a proper rational function. If the rational function is of the form x4 plus 3x cube plus x square minus 1 by x cube plus x square plus minus x minus 1. This is a improper rational functions. When we apply the method of partial fraction, our aim to convert the rational function to the proper rational function. This is a proper rational function, but this is not a proper rational function. So, before using the method partial fraction, we have to convert this rational function to the proper rational function. How we can convert? First, we have to divide x4 plus 3x cube plus x square minus 1 with x cube plus x square minus x minus 1. Then we put here x, that is equal to x4 plus x cube minus x square minus x. Then after subtraction, this will be 2x cube plus 2x square plus x minus 1. Then put 2 here, that is equal to 2x cube plus 2x square minus 2x minus 2. Then after subtraction, this will be 3x plus 1. Then we can write the numerator as x cube plus x square minus x minus 1 into x plus 2 plus 3x plus 1 divided by x cube plus x square minus x minus 1. Then it becomes x plus 2 plus 3x plus 1 divided by x cube plus x square minus x minus 1. Then this rational function will be a proper, now it is a proper rational function. So if the rational function is not proper, first we have to convert the rational function to the proper rational function. That means the function which is in the numerator, its degree must be less than the polynomial which in the numerator is of the higher order. Means if it is a linear, it is a second degree. Means the degree of the polynomial here in the numerator is less than the degree of the polynomial in the denominator. That is a proper rational function. So when we apply the method of partial fraction, first we have to find whether the rational function is proper or improper. If it is improper, first to convert them to proper rational function. This is the method how we can convert the improper rational function to the proper rational function. Then we go to the method of the partial fraction. Suppose this function is proper rational function. Here p of x is, here the p of x is 4x plus 5 and q of x equals to x square minus 5x plus 6. Now we have to factorize the denominator, that is equals to x minus 2 into x minus 3. If it is not factorized, first you factor. Now if these factors are linear, also non-repeated, there are 4 type of categories. One is linear. If the factor of qx is linear and non-repeated. First, if the factor is linear and non-repeated, first we have to convert the improper rational function to the proper rational function. then you factorize q of x. Then the method depends upon the factor. If the factor are linear and non-repeated, then how we can integrate this function? This is one method. Another method is linear but repeated. Linear but repeated. Then how we can integrate? Next, another is non-linear, non-repeated. Non-linear means non-linear means specially quadratic. And another is non-linear and repeated. In this case, how we can use the method of partial fraction? For each case, I shall give an example, then you can solve easily. This is article number 9F in your elements books. So we go through one example for each technique. First, we shall discuss about that if the qx is linear and non-repeated. This is a proper rational function because here p of x is degree of 1 and q of x is a polynomial of degree 2. Already it is a proper rational function. First, we have to factorize q of x. Then the integration becomes 4x plus 5 by x minus 2 into x minus 3 dx. Here the factors are linear. Linear means the power of x is 1. If the power of x is 1, it is called a linear factor. And the factors are non-repeated. None of the factors are repeated. So it is linear and non-repeated. Then how we use the method of partial fraction? So in this case, take let 4x plus 5 by x minus 2 into x minus 3 as a by x minus 2 plus b by x minus 3. If there are three factors, then you can take a by x minus 2 plus b by x minus 3 plus c by another term. First you factorize q of x, then the technique depends upon the factor. There are four cases. One case is if the factor are linear and non-repeated. Second case is if the factor are linear and repeated. And another case is non-linear, non-repeated, non-linear, repeated. For each case, I shall give an example. Then it is easily you can solve the integration by using the partial fraction. So next, our aim to find the value of a and b. How we can find the value of a and b? There are different methods we can find the value of a and b. Take LCM on both sides. 5x plus 4x plus 5 equals to a into x minus 3 plus b into x minus 2. Then denominator on both sides cancel. Put here x equals to 3. This is a easy method. You can find the value of a and b. Also, you can find the value of a and b by equating the coefficient and constant term also on both sides. Put x is equals to 3. Then the left hand side becomes 4 into 3 plus 5. Here, if you put 3 here, then this term becomes 0. So we have b into 3 minus 2. That equals to 12 plus 5, 17 equals to b. That is, the value of b is 17. Next, we have to find the value of a. Put x equals to 2. Put x equals to 2. Then the left hand side becomes 4 into 2, 8 plus 5, 13. A into 2 minus 3. And this term will be 0. that is equal to 13. Here it is minus a. That is equal to a equals to minus 3. So we can find the value of a and b. This is the easy technique. Now the integration becomes 4x plus 5 by x minus 2 into x minus 3 dx equals to, instead of a we take as minus 13 by x minus 2 dx plus b is here 17 dx by x minus 3. Now we can easily integrate it, which is equal to minus 13 log x minus 2 mod plus 17 log x minus 3 mod plus integrating constant c. That's at the integration. Rational function is proper or improper. If it is proper, then you factorize q of x. Then after factorization, then the partial fraction can be carried out. If the factors are linear and non-repeated, then you follow this procedure. If it is factorized already, then you take just a by plus b by. If another term is here, then you take c by. If there are 4 terms, then you can take d by. Then after taking this type of procedure, then you have to find the value of constants a, b. Here there are 2 constants, one is a and b. If there are 3 constants, then you have to find the value of a, b, c, like that. Then after finding the value of the constant, to put here the value of the constant and integrate this integration by method of partial fraction. This is the example. If the factor of the q of x is linear and non-repeated, then next method is if the factors are linear but repeated. Now we go to this second, that is if the factors are linear but repeated. Here the rational function is proper because the polynomial in the numerator is a second degree polynomial and the polynomial in the denominator is a polynomial of degree 3, because if we express detail, it will be s square plus 4 plus 4x. After multiplication, the denominator will become a polynomial of degree 3 and the numerator is a polynomial of degree 2. So it is a proper rational function. But after the factorization of qx, the factors are linear and repeated because x plus 2 whole square means x plus 2 is repeated twice. But the previous case, all the factors are repeated for once, so that is linear and non-repeated. But it is here the factors are linear and repeated. So how we can solve it? You take, let 5x square plus 4x plus 4 by x minus 2 into x plus 2 whole square as a by x minus 2, because this factor is repeated once only. Then b by x plus 2. Though it is x plus 2 whole square, you first take as b by x plus 2. Then you take c by x plus 2 whole square. Then we have to find the value of a, b, c. If it is x plus 2 q, then we can take as b by x plus 2, c by x plus 2 whole square plus d by x plus 2 whole cube. In this way, you have to factorize or we can divide this rational function to the partial fraction. If it is x plus minus 2 whole square, then you have to take a by x minus 2 plus b by x minus 2 whole square plus c by x plus 2 plus d by x plus 2 whole square. If it is x plus 2 whole cube, then you take b by x plus 2, c by x plus 2 whole square plus d by x plus 2 whole cube. Next, we have to find the value of a, b, c. Take LCM on both sides. 5x square plus 4x plus 4 equals to a into x plus 2 whole square plus b into x plus 2 into x minus 2 plus c into x minus 2. Taking LCM on both sides and cancelling the denominator, we have 5x square plus 4x plus 4 equals to like. Next, you put x equals to 2. If you put x is equal to 2, then this term will be 0. Then we can find the value of a, which is equal to 5 into 4 plus 8 plus 4 equals to a into 2 plus 2 whole square, which is equal to 32. 20 plus 8 plus 4, 32 equals to a into 16. That means a equals to 2. It is very important to find the value of the constant in right manner. Otherwise, if you will get the wrong value of the constant, then integration will automatically come. Next, we put x equals to minus 2. Put x equals to minus 2. Then the left hand side becomes 20 minus 8 plus 4, which is equal to, this term will be 0 because minus 2 plus 2 will be 0. Minus 2 plus 2, 0. Next, it is minus 4, which equals to 16 equals to minus 4c. Then c equals to minus 4. Then now next we have to find the value of b. We cannot put any constant to find the value of b. Now we have to equate the coefficient of both sides. The left hand side is 5x square plus 4x plus 4. And right hand side is a into x square plus 4 plus 4x plus b into x square minus 4 plus c into x minus 2, which is equals to a into x square plus 4a plus 4ax plus bx square minus 4b plus cx minus 2c. Now we can equate the coefficient of x square on both sides. Equating coefficient of x square on both sides. Equating the coefficient of x square on both sides. In the left hand side, the coefficient of x square is 5. And the right hand side, the coefficient of x square is a plus b. If you take common s square, then you get the coefficient of s square as a plus b. Since already a is equal to 2, so this implies b equals to 3. In this way, you can find the value of the constant a, b, c. Next, we have to the integration of 5x square plus 4x plus 4 by x minus 2 into x plus 2 whole square is a. A means 2 by x minus 2 dx plus b means 3 by x minus x plus 2 dx, and c equals to minus 4 dx by x plus 2 whole square. That is the partial fraction. That means we have to convert the rational function to the partial fraction. it is not easy to integrate this function directly. So we have to convert this rational function to some partial fraction. Now it is easy to integrate this partial fraction. That is equal to 2 into integration of dx by x minus 2 is log x minus 2 plus 3 into log x plus 2 mod. That is dt by t square. If you take x plus 2 as t, that is dt by t square. Integration of dt by t square, that is equal to minus 1 by t. Similarly, here we will get minus 1 by x plus 2. Minus 1 by x plus 2. Here it is minus. That will be equal to 4 by x plus 2 plus. This is your answer. So here the factor is linear, but the factor is repeated. But in previous case, the factors are linear but non-repeated. Next we have to move if the factors are non-linear. If the factors are non-linear, how we can integrate? Then you can complete the exercise 9F. Suppose the integration is of 5x dx by s square minus 2x plus 2 into x plus 1. How can we integrate this? Here the numerator is a polynomial of degree 1. Denominator is a polynomial of degree 3. So it is a rational function, also it is proper. But these factors are, one factor is linear, another factor is quadratic, but we cannot factorize this. S square minus 2x plus 2 cannot be factorized. So it is a quadratic but cannot be factored to the linear. So this case is a non-linear and non-repeated. Non-linear and non-repeated. How can integrate this? Similarly, you take 5x by x square minus 2x plus 2 as, since it is a quadratic factor and we cannot factorize it, then you take as ax plus b, not a by or b by, take as ax plus b. S square minus 2x plus 2 into x plus 1. You take ax plus b by s square minus 2x plus 2 plus, since it is a linear, so take as c by x plus 1. This is the method. If it is also quadratic, it cannot be factorized, then you can take cx plus d. Suppose this type of s square by s square plus 2 into s square plus 4. Here we cannot factorize this because it is also quadratic. But we cannot factorize to the linear. So in this case we take s square by s square plus 2 into s square plus 4 as ax plus b by s square plus 2 plus cx plus d by s square plus 4. Then you have to find the value of ABC. But here it is a one quadratic factor and another is linear factor. For this we take as c by x plus 1. If it is quadratic, then you can take cx plus d. Next, our aim to find the value of the constant ABC. There are different methods you can find the value of ABC. Take LCM on both sides. 5x equals to ax plus b into x plus 1 plus c into s square minus 2x plus 2. Just you simplify the right hand side. Ax square plus bx plus ax plus b plus cx square minus 2cx plus 2c. Now you can equating the coefficient on both sides. Equating coefficient of s square. Equating the coefficient of s square on both sides. Here the right hand side the coefficient of s square is 0 because there is no term of s square on the left hand side. So the coefficient of s square on the left hand side is 0. But in the right hand side coefficient of s square is a plus c. So we have a plus c equals to 0. Then equating coefficient of x on both sides. Then the right on the left hand side the coefficient of x is 5, but on the right hand side the coefficient of x is b plus a minus 2c. Here it is x, here is also x, here is also x. Taking common x on this term the coefficient of x is b plus a minus 2c. Then equating constant term. Equating constant term. There is no constant term on the left hand side. So the left hand side is 0. But on the right hand side it is b plus 2c. b plus 2c. That is constant term means that is the independent of x. That is b plus 2c equals to 0. Now we can solve these three equations to find the value of a, b, c. Subtracting second and third, we have this is 1, this is 2, this is 3. Subtracting 2 and 3, we have 5 equals to a minus 4c. Subtracting 2 and 3, we have 5 minus 0 is 5. Cancelling b, we have a minus 4c equals to 5. Already we have 0 equals to a plus c. Now subtracting these two equations, minus 5c equals to 5, that is c equals to minus 1. If c equals to minus 1, then a equals to 1. If a equals to 1, then we have 5 equals to b plus 1 plus 2, because c is minus 1, that is b equals to 2. Now, putting this value of the constant in this term, we have 5x by x square minus 2x plus 2 into x plus 1 dx as instead of a we put as 1, here we have x, b as 2, x plus 2 by x square minus 2x plus 2 plus c as minus 1 dx by x plus 1. Now we can integrate these two integration easily. Here denominator is x square minus 2x plus 2. Put s square minus 2x plus 2 as d. Its derivative is 2x minus 2 dx as dt. That is x minus 1 dx equals to half dt. Now we have to arrange the numerator as x minus 1 plus 3 by s square minus 2x plus 2 as 1 minus dx by x plus 1. Separate this integration as x minus 1 by x square minus 2x plus 2 dx is one integration, and another integration is 3 dx by x square minus 2x plus 2 minus dx by x plus 1. Now we can integrate this integration separately. First, this is t, then it is half dt by t. This is one integration. Second integration is 3 dx by x minus 1 whole square plus 1 minus dx by x plus 1, which becomes half log t mod plus 3. Integration of this is tan inverse x minus 1 minus integration of dx by x plus 1 is log x plus 1 mod plus. Then you put the value of t as s square minus 2x plus t, which becomes half log s square minus 2x plus 2 mod plus 3 tan inverse x minus 1 minus log x plus 1 mod plus. Let's complete the integration. Every year one long question from this article. So this is a important article for you. That is the integration of the rational function by partial fraction. In this manner, you can solve this type of integration by using the method of partial fraction. We have also two important formula, that is integration of dx by s square minus s square, which is equal to 1 by 2a log x minus a by x plus a mod plus c. And another formula is dx by a square minus x square, which is equal to 1 by 2a log a plus x by a minus x mod plus c. You can prove these two formula easily. Suppose first formula is dx by s square minus s square. Then you factorize the denominator, which is equal to x plus a into x minus a. You take 1 by x plus a into x minus a as a by x plus a plus b by x minus a. Then taking LCM on both sides, a into x minus a plus b into x plus a. You put x equals to a, then b equals to 1 by 2a. Then you put x equals to minus a. We have a equals to minus 1 by 2a. Now the integration becomes as dx by s square minus s square equals to minus 1 by 2a integration of dx by x plus a. Here we put the value of a as minus 1 by 2a plus 1 by 2a dx by x minus a, which is equal to minus 1 by 2a log of x plus a mod plus 1 by 2a log of x minus a mod plus c. Taking 1 by 2a common, 1 by 2a log x minus a mod minus log x plus a mod plus c, which is equals to 1 by 2a log a minus log b as log a by b log x minus a by x plus a mod plus c. In same manner, you can also integrate this integration and you will get 1 by 2a log a plus x by a minus x mod plus c. These two important formula there are many problems. We have to use these two formula. For example, suppose the integration is as dx by 7 minus s square plus 6x. How we can integrate this type of integration? Which is equal to dx by 7 taking minus common s square minus 6x. You have to arrange this integration to the formula. Dx by 7 minus s square minus 6x. You add here 9 and subtract also 9, because this will be x minus 3 whole square of x minus 3. That is equal to 16. 7 minus minus plus 9, 9 plus 7, 16 minus x minus 3 whole square. That is dx by 4 square of 4 minus x minus 3 whole square. If you take x minus 3 as t, dx as dt, then the integration becomes dt by 4 square minus t square. That is the formula dx by s square minus x square. Using this formula, 1 by 2a, a means 4, 1 by 2 into 4 log 4 plus t by 4 minus t mod plus c, which is equal to 1 by 8 log 4 plus t, t means x minus 3 by 4 minus x minus 3 mod plus c, which is equal to 1 by 8 log 4 minus 3 is 1. So numerator is x plus 1 by 7 minus x mod plus c. So you can integrate this type of function by using this formula. First you go through the examples. There are some important examples in your books. Then you work out the problems which are given in article 9F, and this is an important one article. Every year one long questions you will get. That completes the integration technique of the integration by partial fractions. Thank you all.